I will talk a little about on the topic supply chain attacks and a little on reflections on how we can basically mitigate the risk. And I'm very happy actually to follow the Volvo Cars presentation by NASA, because we are talking exactly into the same piece here. So that's really good. I want to just introduce Grundfos because many of you might not know us. We are working with pump manufacturing. We are the largest pump manufacturer in the world. So the chances are that when you're opening a tap or taking a shower in the morning or heating your apartment, that the hot or warm water will come from one of our pumps. Chances are very big actually. It's a family-owned business, and it was founded just after the Second World War. So I'm a little scared now after hearing Jan in the opening on that fortune and how long companies are actually going to live. But until now, we have at least passed our 75 years birthday. First pump is on the upper right-hand corner there, just for archaeology and this stuff. So these are some of the newer pumps, just to set it into perspective what we're talking about here. Different types of pumps. We are pumping water, not any oils or anything like that. Some of our customers use pumps for that, but basically we are targeting water only. So that can be clean water. For instance, on the right-hand side in the lower part, you have a submersible pump. So you drill a hole in the ground and you get the groundwater up into your house. And we also take out the wastewater with our wastewater pumps. We have one in the left-hand side on the lower part. That one has some knives, so it can basically chop whatever chunks that you leave in your wastewater. The small red one on the left-hand side is a circulator pump, which is circulating heated water inside your house to your underfloor heating or radiators. The other pumps are sort of general pumps used in various applications, commercial buildings, universities, hospitals, one-family homes, industrial processes, dairy, breweries, everywhere where you actually use water, and that is actually quite a lot. I'll not go through everything here. So that is the traditional part. We have now in the last years started to add cloud and services, as many industrial companies do. We're doing that to help improve reliability, give our customers the possibility to actually monitor and control their assets. We do work with larger infrastructure as well in smart cities, where we do flood prevention, moving water from one part of a big city to the other. So it's really different scales, different applications we're working with. But of course, as everybody else, we are adding services, and we can see a lot of value in that. So this picture is actually my picture. Like we saw, NASA had a picture with the Volvo in the middle and a lot of different suppliers around it. This is my supply chain, you could say, my supply chain problem. Because even though we have a service technician here with a tablet, he's doing something with the pump. The infrastructure behind that is quite complex. And the infrastructure we're dealing with when we add cloud to our offerings here is what I have drawn in on this very high level picture. So you have pumps in the bottom of the picture. You have different kinds of controllers, modems, gateways, native apps, Android, iPhone apps talking directly to our equipment. We have local SCADA equipment. We have the internet, of course, cellular network, other kinds of wide area networks. We move data into a cloud where we do have web apps, native apps, and we talk to different clouds and different ecosystems. So this is really a lot of different companies, because as you can imagine, we do not supply all this ourselves from Grundfos. So when we talk about supply chain and supply chain attacks, we typically think of the SolarWinds attack, we typically think IT, but when it comes down to IoT and industrial, then there's actually a lot of places where things can slip. I mean, hardware suppliers, the smartphones. What if a smartphone has a problem? What about our servers? Cloud companies have a hiccup. Whatever chipsets we put into our product, they could even come with a flaw. Our software suppliers, the cloud operating system, protocol stacks, tool suppliers. There's so many pieces where you could actually launch a supply chain attack, even into the area of cybersecurity. So I'm working and mostly in the software area, and that's also what I would be focusing on in these few examples I have brought with me in just a few slides from now. But this is the landscape, and this is basically very similar to NASA's example with the Volvo. A lot of different suppliers supplying into something where you sort of have the responsibility, the legal obligation to provide some kind of service. And yeah, we just heard that from Barbara on standards. They're coming into force now. We have seen security standards been around for a long time, but right now they're actually coming into force. We see it more and more with the NIS2 directive coming out. Even I think it's even they try to speed up the process here due to the incident and the war happening in Ukraine right now. So and that one addresses the security of supply chain. We have the executive order last summer from President Biden, also focusing on enhancing software supply chain security. The standards we look into when it comes into industry, it's the 62443, especially the -4 and 1 and 2, where we have the component security. That one has been around for a long time, I think more than 20 years, and that is also providing requirements for externally provided components. So that is the supply chain. The IoTSF is a standardization foundation organization where we do a lot of our assessments internally in Grundfos. That also talks about the supply chain, and this is really a can of worms we're opening, just like NASA explained. So let me just dive a little into at least some of the risk mitigations that we do in Grundfos. And as I think one of the presenters said, there's a lot to this cybersecurity. It's not just one place. It's not a monolith. It's really a lot of different things we need to have in place. So this is just one thing, the inventory overview. In our AppSec program, we're very much inspired by Tanya Janka and all that she does basically, and she says it's very right here, that you really need to have a complete inventory, because if you don't have an inventory overview and you know what you're actually trying to protect, of course you cannot protect it. So you need to have that. And we also heard that 100 million lines of code and increasing. So all this software coming in, nobody started from scratch. Everybody's taking in pieces, might be open source, closed source, into the software portfolio and building their applications. So a lot of things coming from the outside. So having a complete control is really difficult, and the inventory is what you need in order to help you have that control of what you're doing. So I have some keywords here, what I think is really needed. So the inventory of your assets. Now I'm talking specifically software, but of course it could be also the hardware stuff. But it has to be automatically obtained. So you don't have it will really not work if you have to gather an inventory manually. It has to be complete. Of course, you need the complete inventory. It has to be current. I can live with 1 day old, 2 day old. I cannot live with a month old. It has to be current. Reliable. Of course, you need to trust your inventory. And then if I'm going to work with this on a daily basis, it has to be searchable. It has to provide an overview for you, but you also need to be able to drill down in details to investigate further. So basically, it has to be able to you have to be able to integrate this into your CI/CD pipeline when you do all this continuous integration deployment stuff, and it should help you in decision making. So this is this is really needed when you have an inventory in my mind. And I just want to go through a few examples on how we do it in Grundfos, at least for inspirations. And then I'll come back to what is missing, because as NASA pointed out, there's really a lot of things that we still need. So one thing is that we use a software composition analysis tool, where we basically scan all our repositories with the software. That is both the embedded software, so that's the software for the pumps, for the controllers, for the smartphone apps, and also for the cloud. So we basically scan all our software. And to give you an example here, this is back from January. There was some URL parsing libraries where there are problems. It was actually a leftover from the Log4j vulnerability. And basically, you get the intel. This is from the Hacker News. You could see it in a lot of different places, that these components are vulnerable. They're CVEs. Okay, what to do? If I just look into our portfolio, we have a lot of different technologies, and I need to sort of figure out, well, is this at all applicable to me? So I can look through here. I see there's something in JavaScript, something in Python. Okay, PHP and Ruby we don't have, but Python and JavaScript probably. So I go to my composition analysis tool, which is this one here. Here we have all our projects. When I go down here, you can see in the right lower part here that we have around what does it say? 349 projects here. So a lot of different projects are scanned. Some teams choose to scan the software in different stages of the life cycle, but really to get the overview. So I can go in here. I can of course look at different projects, but I can also just search for it. Which was it again? It was for instance, I could look for the Flask component. Am I actually influenced of this? Are we hit? I can see we're using something here. I can see a few number of projects are using it, but it was actually only Flask security, Flask on-chain, and Flask user. And when I scroll down here, I will find that, okay, I'm not using these particular components in our software. So that actually helped a lot. I did this search manually, but actually I could relatively quick find out whether or not this applies to our software. So a few other examples here. I just noted here that we're using the software composition analysis also to keep track of the open source software and the license stuff. That is a completely different ballgame, but the tool is good to do that as well. So here, the second is a malware which were discovered in a UA parser library back in October last year. So basically, the UA parser library is a JavaScript thing. When you have a web application, it will check something about the language settings of the browser and stuff. But what happened was that there was released new versions, this 729, 8.0, and 1.0.0, and they were released by a developer, but this developer was actually, his account has been hacked. So it was a hacker who posed as this developer and released the new versions, and there was added a few extra things in it. The things that actually stole credentials on Windows and Linux machines, and also did some Bitcoin mining stuff and sent everything off to a certain destination, unless your browser was working in Russia, Kazakhstan, and a few other places. But of course, we don't want to have this kind of stuff in our code. So again, I could go up and I can just look for this this UA parser and check in my inventory, and I actually find that yeah, we are using in fact this UA parser. It's a pretty common library, but here I can also see the versions. I can see that I actually have one project using 28 and 4 projects using 31 and 7 projects using 22. My problem here is the problematic versions are 29, 8.0, and 1.0.0, and we do not seem to use that. So probably I should talk to the team working with this version of the component that you shouldn't really update to 29. You should go directly to 30. Right now, this component, the 29 version, has already been removed from the repositories out there, so it's not possible. But in principle, I should alert them that they should not update and should jump to the next version instead. So the last example here on inventory and how we work with it is another case. It's actually a nice case of the disgruntled employee, or at least a variant of it, because that is in the NPM area where a few components called colors and faker were actually use quite a lot. And that particular open source software developer, he grew tired of doing that. I think that's the way the story goes. And he just released new versions, which basically is filling up the UI with a lot of gibberish. So let me just take a check on that to be to see if we are using that. I'll just take the colors, which is in version 1.4.0, which is good. And we are using some versions here of the script here in 1.4.0. Actually, he released the Faker, I think it was, that was released in version 6.6.6. So it's pretty easy to recognize. Colors were released in this bad version in 1.4.1. But of course, we are not using that. And that was also relatively quickly removed. This kind of incident is something, of course, we would find in testing. But yeah, it's really important that you have the inventory and you're able to search through it. What happens is also that if you're going to do this manually, then you'll be facing a huge problem, because even though you have a component which is today without any security vulnerabilities, then what happens in 3 months if something pops up? You need to go through all your inventory regularly if you're doing this manually. Absolutely impossible. You should find an inventory tool that can help you do this. There's a lot of tools out there, both commercial ones, but also open source ones. And you need this to happen automatically. This tool we have here is giving us a heads up if a new security vulnerability is found, and we can react to it and add it to whatever intel we have. So my last slide here is basically remaining challenges, and we have heard already a lot from Volvo Cars, and there's really a lot in this area. So all these open source packages, also closed source packages, how are we building trust if we as a vendor should release this with a good confidence and also prove that this is actually cyber secure? We need authenticity. How to do that? Today we can basically point to NuGet packets, npm packet servers, and basically cross our fingers that things are good. Could we do this somehow? I know it's open source. There's a lot of different questions here. So how do we secure authenticity? Even already released versions that have been good, how do we make sure that they're not changed? All the intelligence, we have scattered overview in different databases, the update speeds. And basically what I want is I want to be able to react quick. I want to get the intel quick, and I really want the tools to help me here. And then for closed source, of course, we have suppliers. This cooperation, it's basically a lot around trust, because it's really hard also for the suppliers to us to justify or to prove that their components are without any flaws. Yeah, and my last point here, I don't want to have false positives, because this is really killing it. If I have 100 hits and then 99 of them are false positives. So that was actually my presentation. I'm actually just in time.